All right, shall we start? Yeah. Okay. So as I was saying, I'll start for the third time. So this book, I was talking about thinking fast and slow. So this book, I haven't finished yet, but it really changed the way I think, because it made me realize how biased I am towards certain things that I do. So sometimes we do things because either someone told us, or we heard so many times that that's the right thing, then we just believe that it's the right thing, and we stop questioning those things. And since, like, I don't know, 6 months ago, I started questioning how I work and all the techniques that I use, and understand, like, if I use them because I believe in them, or it's because it's just how I learned it, and a lot of people that I respect said that it was the right thing to do. So, how many of you use TDD? I would be very disappointed if I didn't see it. So, in the craftsmanship community. So, how many of you think that TDD leads to good design? Okay, you are biased now, right? Because you know the talk. So, because I said that for many years. Like, if you go back to my talks, books, and everything that I've said in the past 5 years, you will find in many places me saying TDD leads to good design. TDD leads to good design, and I strongly believe in that. The interesting thing about it is, why is it difficult for other people, right? And why is it not that difficult for me? But not only for me, there are a group of people that have no problems, but other people struggle a lot. So I was always thinking, why? And so, as soon as you, another thing, like, a lot of people can test drive the code, but not always the design is quite right after that. So what is missing, right? So I was thinking about that, and then, what is the life cycle of TDD? What are the 3 steps? Right. Put it in here. Very fast, right? So that's what we learned. Doesn't everyone understand this? Right? Have you ever explained this to someone and the person didn't understand? Because, like, there's no way not to understand this, right? You need to be a retard if you don't understand. Like, write a failing test, make it pass, make it better. You cannot not understand this, right? But applying that and achieving what we want to achieve is a completely different thing. So if this is so easy to understand, why is it so hard to do? Right? So, where is the design here? So, in TDD, where does the design happen? Refactor. What do we do in the refactoring phase? What's the guideline? Make code better. How do we do that? Right, so maintainable, readable, all the all the abilities, right? So, what is the prescription here? What do we do? So just make the code better doesn't help. That's why we fail, right? So you say, make the code better, right? Yeah, how? What are we looking for? Generalize it. So, has anyone ever heard about the 4 rules of simple design? Yeah? What are they? So, I'll put in any order, right? Duplication.
Pass the test.
Pass the test, that's the first one.
No duplication. No.
Fewer elements.
So, fewer elements is the last one. Fewer elements. And
revealing time.
Revealing times. So you find these written in different ways according to who wrote them. Where does this come from?
Back.
Kent Beck, right? Part of XP from the simple design. Is this part of TDD?
No.
No, it's not. So I asked Brown Jeffries, Infinity Sparks, and he's one of the creators of TDD, of XP, alongside with Ken Beck. And it's not. So this is not TDD. Where's the design part of TDD if that's not part of TDD? So how come it's a design tool? Right? So for me, this thing is not a design tool. I changed my mind. So I've been inspecting how I work, and I completely changed my mind. For me, what this is a software development workflow. It's different. So this is my turn to write a failing test, but that means I specify the behavior that I want my system to have. This is me implementing the behavior that I want my system to have. And this is me trying to figure out, best of my abilities, how to make that thing better. But I'm completely on my own. So if I don't know about the 4 rules of simple design and many other design principles, there's zero prescription in here. Right? So why is it difficult? Because this doesn't prescribe where do you start. So you have a feature. So you probably experienced that. Like you have a user story or something. You give that to different developers. And each developer starts from a different point. Some start from the middle, some from the beginning, some will start with the DIO or whatever, like the repository, whatever. There's no prescription in here. So all these decisions, like just the simple decision like, I'm going to start from here, that's a design decision. That has nothing to do with this. Right? So, and even when you say, I'm going to write a test, but you define which class you're going to have, the public method, the signature, the return type, this is all design. And at that point, it doesn't matter if you're doing that. You already decided which class you're going to have. This is not helping you with the design. Design is coming from your head. Right? So, but not all TDDs are the same. So that's another very important thing. TDD is not, today is not a single thing. What are the 2 main styles of TDD?
London.
Okay, let's call it London for now. What is the other one? Classical. Right? So, so you can sometimes talk about processes to a Detroit school. You can talk about outside in or London school. You can talk about mock East. There's no inside out. It's important, right? This prescribes direction. You start from outside, you go to the inside. This doesn't prescribe direction. There's no style called inside out, right? So they are not opposites. They are different styles. They don't rule each other out. You can mix and match, right? There is a big debate of if it's Detroit, Cleveland, Chicago, the whole United States, and mock East. This doesn't even make sense, right? Because mocks are also used in here, right? But not in the same way that it's used in here. So let's talk more about these now. Let's try to understand how these different styles impact on design. So, in the cost-assist approach, design happens here. Right? I'll put a C in front of it. That's where design happens in the cost-assist approach. The type of tests. So when you have like in a unit test or whatever level, you have like your given when then or a range, act, and assert, whatever name you want to give them. How does the assertion look like? What type of things are you testing there? Is it more like getting some state out of the, normally it's like we call a method, get some stuff out and then test. So class-assist approach is a state-based tests in general. But there are no rules. There are people who do different ways, but on average, the type of tests that we do using the class-assist approach are state-based tests. So during the refactoring phase, in the class-assist approach, the unit under test may become bigger. How does that work? So you have a test. Right, I'll put tests in here. You have a class under test here. And then you write a single test. And then you write another test. And as you start writing a few tests, this class starts getting bigger. Right? And you are using your refactoring to start extracting private methods and stuff. As soon as you see private methods that work together, are cohesive, you end up, as you grow these, you end up extracting these things like that, right? So what started as this single unit under test, as you moved forward, so the unit under test became bigger. That's normally the classicist approach, right? You don't mock those dependencies. That's how you would go about it. You make a small mess in here first, and it's totally fine. You reason about that mess, normally using guidelines like for rules of simple design or other things, and then you end up in this. So the interesting thing about this one is that there's no upfront design. So one of the characteristics of the classicist is that you design according to feedback from your code, right? So normally you minimize upfront design. You look at it, say, okay, there's duplication, the names are not correct, so you design only when you have feedback. It's much easier to understand. A lot of people start with this approach first because what you do, instantiate a class, call a method, get some state out, assert on that state. It's very easy to test drive in the classicist approach. Very easy to explain. So it's good for exploration. So when do I use this? When I don't have a proper domain. So for example, if I'm doing an algorithm, data transformation, stuff like that, there's nothing that I can anchor my thoughts. So even if I speak to my domain experts, product owners, wherever, like there are areas of my system, they say like, this is your input, that's your output, but whatever you do inside is up to you. There's no domain concepts in there. So when I'm in that type of situation, this approach is very good because I can work in small increments, start writing tests, look at my code, extract, but I cannot anchor my thoughts into a client, a user, a trade, a payment. There's no domain concepts in that. Of course, you can use the actual business process. I'm saying when normally I prefer this approach. So this is good for that. So what are the problems of this style? When you have a user story, where we are providing a system, normally what we want out of our system is behavior. Every time I talk to someone, the features are always behavior. We want to enable our users to buy some stuff. We want be able to provide the search capability. We want be able to extract some stuff and report to regulators. So we want to buy some stuff on our shop. It's all verbs, right? We want, if we are all focusing on, if what we are trying to achieve is about verbs and behavior, why are our tests about state? Right? So how much does this impact on our design if you are trying to provide behavior but we check state? Right? So once the unit under test becomes bigger, it's not a problem because like a lot of people say, yeah, but that's fine because this is has loads of advantages and stuff. And another problem that I see is that when we see people on the internet and people that you may follow somewhere, and all the examples that they use are very simple. And normally they use contests to demonstrate stuff. And when you think about this, it makes sense to be like, if I put mocks on this, and inject, it will become far more complicated. So why we would make these more complicated? The problem are our systems are not that simple. This is okay if we stop on this feature. But what about, so this is feature 1, right? So what about feature 2 now? That will follow a similar approach. So I will have the tests. I will have a class in here, right? I will do the same thing. This will start growing. Some domain concept extracts in here. And all of a sudden, as we are growing this test, and everything is being tested from here, so, oh, maybe we could reuse that. Because now, once you extract the classes, they have a different life cycle. As soon as you made these classes public, they now are part of your domain. Right? They will evolve independently from each other. So you may end up in a situation like that. Right? And of course, I think that you can already visualize that you may have feature 3, and so that would be F, and that may be something, I don't know, something like that. Yeah, no, like that. So, now the interesting thing about this scenario, if you're doing like a CRUD application, that may never happen, right? So each feature goes from the page to the database. They are horizontal, and they don't mix each other. Like, so there's no conflict between inserting a client and inserting a product. But if you're doing something that is far more interesting, with a richer domain, the middle of your application will be quite rich. So that's when you may end up with this. And then all of a sudden, because now we have 3 different features, putting pressure on this class to evolve, this class may evolve. So we can have another class in here. As soon as you do that, the constructor of this class may change, or this class may go to a database, or talk to an external system. And all of a sudden, because we are trying to develop feature 3, all the other tests that are completely unrelated are broken. Does it happen very often? It depends on which type of application you have. Once again, if the features don't conflict with each other, they're very simple, you will never have this case. Who are the main proponents of these things? Normally people that work in web apps. So although it came from Smalltalk, but a lot of people using these, they work in simpler applications. That's why TDD evolved and had a different style, because this simple style you struggle in a more complex domain. So I just need to. Another thing that is interesting with the class-list approach, imagine that you have, your system is something more complex, right? So there is an input into your system, that may be an HTTP call, a message in a queue, whatever that will be, right? A mobile call. So there will be a class that will handle that, we call other classes, right? There will be stuff, and then at some point you come here, that will go out. Something like that. Class-list approach doesn't prescribe anything. So for example, you may say, oh, some people prefer to start from their domain. So, oh, I have this payment thing, and I know that I will need this payment thing, so I'm going to start testing from here. That was already a design decision. That has nothing to do with test-driven development. You haven't even written your test yet, but you decided to start with a payment class, with a user validation class. You don't even understand how this is going to connect yet, and you are already defining a domain class with a public method, with an interface, and then at some point you need to connect in this. All these decisions are not TDD related at all. You want to test that thing, but the choice of starting from here was yours. Defining the granularity of here, of this class, was yours. That's why TDD gets very complicated, because TDD is not prescribing any of this. TDD is saying like, okay, what do you want to do? I want to do this. You made the decision of what you want to do. And then I'm going to test drive what I wanted to do. What we like to think that is helping us. Well, it may. In cases like where we need to explore, like as I said, there's no anchor point in terms of domain. So, but the choices that we make in here is what is hard. That's why certain people cannot test drive code, because they make very bad choices in here. Or they get into an entanglement, and then they change one thing and breaks all the others. There's nothing to do with any of these decisions, right? So, another thing, it's the class-assist approach is very wasteful. Very few people talk about that, because they say, no, that's awesome to work in big steps. So now let's think about this scenario. I have e-commerce application. So I go there to the website and search for a few books. I add them to my shopping cart. I go to the payments page. I fill out my payment details and say, pay. So there's a button there that says, pay. That will send like my basket, my payment details, who I am, and all this kind of stuff. Our user story is something like, I need to validate the user, and then I need to figure out if the user has bought stuff in the past, calculate discounts. Then I need to call on a payment gateway, figure out which type of payment the user is sending, and then I need to notify the delivery system or the logistics system to deliver that thing, and then I need to send a confirmation email. So a single call from outside will trigger a very, very big flow, right? Would we have? So imagine this is a user story, and all these things that I said are part of the acceptance criteria, right? Would I have all this code inside this one single public method? Would we build a full system with all the features that I mentioned in one public method? I believe that we wouldn't. I hope that you would. So why on earth would I use baby steps on this? Why would I have one class, small method, wait for the validation to come out, extract, and then wait for the payment to come out, everything from here? So the reason that people say that it's okay because we are working in small things. But you don't design an enterprise system, a large system, from one test in one class in one method. You need to start saying, I will have a user validation, I will have a payment gateway, I will have like a delivery system. So that's when this goes wrong. That's why it is so hard. Because it's finding this balance of when to use baby steps, when not to use baby steps. Right. And I think that this approach, if you follow exactly this approach and wait for your domain to emerge using baby steps, that's fucking waste of time, right? It's pointless. We know that that code won't be in that public method, right? So why not go to the proper object? So I think so. A lot of teams doing that. The amount of time that they spend refactoring the code is enormous. Every new thing is a refactoring, but we learned that refactoring is good. Good for whom? Someone is paying for that, right? It could be a little bit smarter how we go about software. So, okay, that's class 6. I'm not saying this is bad, by the way. I'm just saying the characteristics and some problems that you may have, not that we will have. Right? It's very clear. Outside in. So those are so what I said was how the classist approach has an impact on your design or not at all. Outside in. Normally the way we do things, you have an input to your application. That will come to a layer here that is, I don't know, maybe some controller, some API, some whatever. There is some class that will handle this. Right? There is a request into your system, someone needs to handle that. So so outside in prescribes direction. So we always start from the first class to handle the input. So that's already a design decision. Can you do the same design style without any TDD? Of course you can. Right? So you already know. So you prescribe a design direction, but it's not telling you to test it. Right? So, and then, of course, in that scenario that I gave, payment and user validation, blah, blah, in the outside in, the way we do it, so we have things like user validation. You have like a payment gateway, or make the payment gateway. We have like a delivery. I'll put just random stuff. And then notification, right? So notify the user. Notification. So the way we do things is, we know that this class cannot do everything. Jesus, I'm boring. So what we do, we go to the acceptance criteria. So we have a user story. There is an action in that user story. You want to buy some products, that's the thing. We go to all the steps. So what are all the steps for this feature? As we reason about these steps, that's when we start thinking about what are the collaborators that we need, because I won't build the whole thing in here. So I may need a user validator here. or a user class with a validate method, whatever. It doesn't matter in this case, right? So just bear with me. So a service, whatever you want. But I will have a piece of code that will do some validation. According to the complexity, this will vary a lot in where I would put. I will need a payment gateway, right? I need something that will handle the payment. That will check the credit card. So, credit card. That will explode that. There will be a notification. Maybe the notification will come from the gateway. So all these things, what we are doing, we are taking nouns and verbs, and we start modeling. But the difference that this style has in the design is, first it's prescribed direction, but also every single class needs to, the only reason for this class to exist is to serve this class. So you design this class to serve this one. So basically this one has a need, and so I need to do loads of things, but I don't want to do any, to worry about the specifics. So it would be nice if I had someone that could do that for me. So the API of this class is designed to satisfy this class, right? So that's the outside in. And then in the test, you're going to mock these things. But every single class only exists to satisfy the client class. That's how you design, coming from the input to the output, or from the outside to the inside of your application. That is the outside-in approach. There is a little bit more to it, but there is an interesting thing about this. When I started thinking about these forces, right, and at some point it's going to go out or send an email or whatever. There is an interesting thing about this. So there is an execution flow. That's the execution flow. Execution flow. There is the test flow. And also, there is the design flow. They are all aligned. They are all pointing to the same direction when you think about this. So now back to here. Where does the design happen in outside in?
Red.
Exactly. Design happens here. Right? I'll put a no, say outside in. So if the design happens at test, the test is not helping you at all. What your testing is doing is just creating that space on your workflow and say, this is your time to design, to think about the behavior that you want and how your system is going to look like. But at that point, your test, the other one was state-based. This test is behavior-based. That's one of the characteristics, because what you're doing is, I'm going to test my controller API, whatever this is, and how the data that it receives, I will check if it's calling this guy here with the right data. And then, according to how this guy here responds, I will make sure that it calls. So the test is all about the collaboration. So it's not asserts anymore. You are verifying stuff now. So design, you have no code to give you any feedback at all. While you're writing their test, you need to visualize where your collaborators are, define how they're going to collaborate, their integration, and specify their collaboration in the test. But that's not the test telling you. You are imagining how you want your system to work, and you are just writing it down in a test format. But there's no feedback. Well, the feedback is the correctness of what you already decided. You are checking for correction. I want my system to behave like that, and this test is only telling me if it's working according to how I want it or not. But there's no feedback. You are completely on your own. What about the refactoring? In the refactoring, the outside in, there is a refinement. So you design here, but not always you're going to get the design right. You design here, you make it work, and then when you look at it working, you say, do I like what I created in here? If the answer is yes, you move on. If the answer is no, you need to refine your design. So those are the different forces that you have when you are using the different style. But in both, when I analyze how I code, the design is coming from my head. Right? That's an interesting thing. There is also, of course, that on the outside in, you may have the outer loop as well. Right? So that is. So this is the double loop of TDD. Yeah? We start with an acceptance test, and then before you go anywhere, so you decide your acceptance test. That's what I want. I will have this input, and I want this side effect in here. Right? That's your acceptance test. Your acceptance test doesn't care about this, let alone all the internals. You say, I'm going to send some stuff to my system, and I want my system to do something for me. That's what you write in these acceptance tests. And then what you do, you don't go and start hacking about. So, okay, now you go down one level. Say, now we're going to start unit tests. What is the first class that's going to handle that request? What are the collaborators? Then you normally mock the collaborator. And then you start. So then you are red wing refactor, red wing factor, red wing collaborator, red wing factor for them until the last collaborator goes green, is implemented. Then automatically, then you check if everything is okay, and then automatically these features should come to green. Look at the acceptance test if it's exactly what you wanted. Refactor if it needs to be. Start new features. So that's the outside-in approach to TDD. The problems. You want on your own. You make assumptions of what the collaborators are, how they're going to work. Right? You have no feedback. If you are good at design, you'll be more successful. If you suck at it, you struggle like hell. So, I covered that. This approach also favors the tell don't ask. Have you heard about tell don't ask? Yeah. Right. So this approach favors the tell don't ask. So you tell objects to do stuff for you instead of asking the object to give you some data and then operating on it. So the tell don't ask approach is more aligned to a good OO approach. It's like in the original days of object-oriented programming, the objects were sending methods to each other, calling methods on each other. But is tell don't ask part of TDD? No, it's just a design style. It's a design technique, I would say, that you use. Can I reach exactly this thing without a single test? Yes, I can. I'm just decide where I'm going to design from, what are the techniques that I'm going to use, just provide classes that work. But this has nothing to do with tests. How I divide these things has absolutely zero to do with TDD. Zero. So this style, the outside-in style, is far more suitable for business applications. This is it's almost impossible if you're doing an algorithm or data transformation or things that there's no anchors, there's no domain concept, there's no nouns or verbs. It's basically there is a massive input, a massive output, nothing for you to anchor. You cannot use this. Plasticity is far better. But if you have anchor points, nouns and verbs, right? A payment, a user validator, a notification, credit cards, you have domain anchors that I call. When you have domain anchors, if you have a good eye to understand nouns and verbs and how these things could collaborate, and things like bounded context in domain-driven design, it's much easier to use this approach if you are in a business. Where the classicist approach, this would be extremely wasteful because we are throwing away decades of design knowledge just because someone in the craftsmanship community said that you should start test by test using baby steps and using 4 rules of simple design to build a beast like this. It's nice when you do your Roman numerals kata, but you don't build a system using baby steps, 4 rules of simple design. Well, you can, but I wouldn't pay for it because it would take forever. Right? So, problems. Much harder for novices to do. People starting with TDD, this is extremely difficult. Is it because the technique is difficult? No, it's because the design skills are, you need far better design skills to do that. Because the other one, you say, call a method in one class, pass some inputs, get the output back, assert on this. And then you build the entire system bit by bit. But this is much harder to do. There's no feedback, which means that you need to visualize your domain concept. incompetence. So you need to speak to your product owner. You need to understand your domain well in order to be successful with this approach. You cannot just hack code. You cannot explore. This is not for exploration. If you are in exploration mode, use the other approach, because your domain is not mature enough for you to anchor. So, may lead to over-engineering. This very easily, because you are on your own, I will need all these classes. I will need to put this. There's no constraint. Right? Because you write your test first, there's no constraint there. You decide how the collaborators and how the pieces are going to fit together. And it's not that hard to test that. So, bad design will lead to mock hell. A lot of people say, oh, my mocks and mocks are blah, blah, blah. You cannot blame a library for your own incompetence, right? So if you say, oh, I have loads of mocks. Yeah, of course, you have a lot of coupling. You don't have a lot of mocks, you have a lot of coupling, right? All your classes are talking to each other. So, or you have things like method A goes to object B, gets object C. So then they mock B, they mock C, and then they call a method on C that is a mock that you call D, then they mock D, and they get a response. You are violating law of the meter, right? Or don't talk to strangers. So you have all the problems that you may have with mocks. I challenge any one of you, show me your code, and I'll point a design flaw in it. It will never be a mock problem. Mock is just a library. It's a technique. You cannot blame mock, right? So the lack of domain-driven design, because you need to understand domain-driven design as well to define your bounded context. Right? As I was saying, when the features don't clash with each other, understanding this bounded context is very important. If you don't, this will be a nightmare. So, how many of you heard either someone told you or you told someone, like, listen to your tests? You heard this? If I said that to someone, some of you, I'm sorry. Because that was a very bad advice. So, let me try to explain. So, I was, myself, my wife, and a friend of mine. Same age, all Brazilians, moved to England, roughly same time. So we had our youth, like our teenagers years, we were in Brazil. We were talking about music, the type of bands that we would like, we listen to. So then my friend and I, we asked my wife what type of music she liked. Then she said a few names, and then my friend and I said, ugh, how could you listen to that crap? And then she felt offended, of course, right? So, and then she said, well, okay, what did you listen to? And then I mentioned the things that the type of music that I used to listen. Both my wife and my friend were like, how could you listen to that crap? And then my wife and I looked at each other and said, okay, what about you? And then said, oh, I used to listen to this, and said, how could you listen to that crap? 3 people, same age, we couldn't agree on that. But then we started saying, well, why do we disagree? For my wife, good music means dancing. She loves to dance. So when she goes out, good music for her is something that makes her feel happy and so have fun. That's for her what good music is. I don't like to dance. So for me, good music was about the lyrics. I always liked political lyrics and all this kind of stuff. So that's why I went to punk rock. But my friend was a musician. He couldn't care less about the lyrics or the rhythm. What he cared about was the technique that the musicians were using to play the music. So he cared, like, for him, good music was like how good the musicians were, the work that they were doing. So when you say listen to your text, that's a completely stupid thing to say. If you don't know, if you don't explain what you should listen for, right? So I think that sometimes you look like a fucking guru and say, come on, son, just listen to your test and design will emerge. That's stupid. That's not going to work. There are decades of design knowledge in there. And then you expect, because you put yourself in an ivory tower and say, just listen to your test. And expect that this person here will, at that moment, in 20 minutes or in an hour or in a day, come up with everything that was ever created in software design just to solve the problem. How stupid is that? Right? How egocentric is that? So, right, that's outside in. So those are the 2 main styles, and that's how they impact or they don't impact, but the forces that they have in your design, right? But then people will say, no, tests are good because it constrains you. Cool. So type of features. You have from very simple, to very complex. Right? So if your features, they fall into this category, they are kind of simple features, the test won't harm you enough for you to rethink on your design. Because a lot of people, no, the tests it's a design tool because it will constrain you. If it's difficult to design, or if it's difficult to test, you should rethink your design. Yeah, only if we assume that every single feature in our system are here, in the very complex one, where testing the whole thing, the scenario that was given in one go, it would be very complicated. But if your features fall into this category, the test will hurt you. And that's when we say, because you can speak to a lot of people that prefer the classist approach. So for example, a lot of all the very good TDD practitioners that I know, they mix and match. They use classicist and outside-in, because like the features don't fall into a single pattern. Right? So in a system you have complex features, simple features, complex features. They have features that are very large, features that are data manipulation and algorithm, features that are normal, traditional CRUD or domain. You have, a system is not unique, like in terms of features. The features are not unique. So you need a combination. But, as I was saying, why do we have people that say, my default style is a classicist, and they don't struggle, they don't have the problems that I showed. And then you go to some guys more in London and stuff, they use a different approach, and the classicists say, but you would have this mock health. No, we don't. So when you take people using two different styles, even to solve exactly the same problem, and they say they don't struggle, the few that say that, they share one thing. They understand software design very well. That's what they do. So when you understand design very well, it doesn't really matter which style you use, because you will be able to understand coupling, cohesion, the forces that, for example, the more generic your code is, the more decoupled, the more unreadable it is. So there are opposing forces as well. They will be measuring all these things. They will understand bounded context, so to avoid conflicts of features, even when they are related to what looks like the same domain concept, but maybe it's the same domain concept, but in a different context. And that's how they are able to decouple this. And these things are not TDD. You need to understand this. So, that's your own development not constraining you at all. An example of this is, if you have a method that's very simple, you receive a list of numbers and you need to sort them, right from the smaller to the biggest, the smallest to the biggest, and then you return. You can easily test drive a bubble sort. But if you don't know there are different types of sorts that are far more efficient, you will never test drive that. Right? And this is the same for business code. When your features are here, you can come up with a very simplistic design, and your test won't put any constraint on you, but you come up with a very bad design, but because you don't know that it could be designed in a better way. So that's the same thing for the business code. So let's move on because I will run out of time. I can stay here forever talking about this, right? So
10 minutes.
Huh?
10 minutes.
I have 15 here. Huh? I put an hour and 15, but that's so, right. There are things that you cannot test drive. So there is, you have an application. This application talks to different applications. So that's application 2, application 1. And then inside an application, you may have layers. You may have your hexagonal 1, 2, 3. Yes. So hexagonal architecture. So so you can talk to messaging system, all sort of stuff. Here you have your blah blah blah, your classes. So for me, The external stuff, choosing databases, how you communicate to other systems, if you're going to have a web app or if you're going to have mobile and web, for me this is all architecture. It doesn't matter if you agree or not. I think that it's just important to define the boundaries so we can have a conversation, right? So you can disagree with that. So this outer part, out of my box, for me that's normally where the realm of architecture. They don't test drive that. There's no way. If you are trying to test drive that, it will be stupid. Because these are things that you take planning up front. Right? Are you 2 developers or you are 20? Right? Are you going to a small startup that you are just trying to get something out and see if it would work? Or you are in a much larger company that says, we need to replace some existing systems. We know the domain quite well. We just need to replace them and rejuggle the type of systems. And you have a 2-year period to do that to start new. Your application lives in a whole ecosystem. You don't test drive that. So that's Then I have a distinction between macro design and micro design. So for me, macro design is where layers, hexagonal architecture, those are macro design for me. The way that you define your components as well, your package, your namespace, that's for me all macro design. MVC, all sort of stuff. Micro design is what I do in each class. TDD will help you a little bit more in here, but not here and not in the architecture item. So that's another thing that is important to understand. How do we reason about design? So this is straightforward. This is future-proof. So those are trade-offs. And this is a timeline. Based on what I was trying to achieve, I was trying to understand why I don't struggle so much. But most importantly, why some people don't struggle at all, and some people struggle a lot with all these things. Where the design ideas come from. So if I gave you like a feature, why do we start from different points? Like we have like our recruitment process, we give a coding exercise to people. So we get a lot of submissions. The degree of code that we see is huge, and also the decisions that are made in terms of some of them have extremely, extremely simple solution almost in a single file, right? At least throw away, of course. And then some of them are extremely over-engineered that we also throw away. So, well, we give them a lot of feedback, of course, before. So, the thing is, every time, regardless if you're test driving or not, when you decide to start from somewhere, so I'm going to have this class, this layer, this amount of collaborators, I realize that at least what I'm doing and many other people are doing, they are trying to understand, to reason about how straightforward or how future-proof they are trying to make that piece of code. So, what are these things in here? They can be, for example, things like performance. They can be things like security. But they can be things like, for example, American Express, American Amex, or different types of payments, so payment types. They can be different types of trades, trade types, whatever, so different flows. They can be functional or non-functional, that's what I'm trying to say. So, there is a thing in here I think what I'm trying to say is when you decide to start from somewhere, the reason that I say I think that this is we should only have this amount of code. And then it's either decided to have this amount of code, and the match decide to have no code at all or go close to nothing, as is normally the case. So, but what we are all doing is the reason that maybe Sandro decided, I think that we should have this interface in here. We should have this repository layer. We should have a hexagonal architecture. We should have a type. We should not use a primitive. All these decisions, you are not test driving them. You are making them. What you are doing, you are moving this slide either towards a very straightforward solution to your problem, or in your head, even if you don't reason about that explicitly, but implicitly, according to your previous experience, you know that if you code in a certain way, you have problems in the future. So what you are doing is you are trying to have some sort of future proof. So you are moving that slide. So if I had this layer here, it would be better because that will avoid. So you are moving from here to there. This is what I call inflection point. The inflection point can be in any place, can even like go across. This can be another inflection point. Inflection point is when you are going up somewhere and then there is a point where it changes, the curve changes. So what do I mean by this? So design is all about trade-offs, right? So as you move this thing to a straightforward solution or to a more complex solution or future-proof solution, you are making trade-offs. If you make it too simple, you will need to rebuild that to build a more generic solution as soon as you start introducing multiple types of payments later on. So you lose flexibility. You made it simple, but you lost flexibility. That's the trade-off. Here, you are more prepared for new changes, but you made your code far more complex as well. Those are the trade-offs that you make. So these trade-offs, they happen not only on the functional, but also is how much you know about what is coming. So we know that for our MVP, for us to go live, we need to accept Visa and American Express. We are currently working on the Visa. And we know for sure that the next feature, because it's been at the top, it's been agreed, blah, blah, is American Express. Can we, instead of doing a very simple thing in here, and have to rewrite that thing for this one in here later on, can we just move this a little bit and let our system be prepared? For example, why do we go for microservices? Right? Why do we split our application in different modules? We are looking at one of these things. We want people to work in parallel. I want to deploy these things in isolation. I want to scale things independently. I want to use different technologies. This is all future-proof. Do you need it right now? No. But what is the price of doing it here or here when it comes to the timeline? So do I want to not pay this price now, but maybe create a beast that I cannot split later on? Or I will pay the price right now, even knowing that I may not even need that. So the point is, we went as an industry, I think, from big design up front when I started in the 90s, to now, in this whole Agile craftsmanship thing, with this madness of, we went from big design up front from here, to this madness of no design at all. Everything is TDD baby stuff. That's stupid. That's completely stupid. Because that's not how you build large systems. Do that for your kata. But that's not the world that I live. So, the art is here, and that impacts heavily in your test drive. See, there's nothing to do with TDD. All these decisions, the vast majority of the important decisions that we make, have nothing to do with TDD. TDD will help you to get there, to make sure that you are working safely. But those decisions are far more important. They have a far bigger impact on your software than your variable name, your small rules in there. The art is defining where this is. Because you don't want to be here for sure. If you need to err, you should be here. But defining this is important. There are different ways of defining that. I have 4 minutes. Let me stop the clock for them. So, there are 2 ways of getting to this. First of all, I'm going to define, and it's a long definition. So, the way that I'm thinking about this is the inflection point defines the maximum amount of investment we are comfortable to make in a desired type of flexibility at a given point in time. And beyond this point, the investment is not worth anymore. That's how I define this. That's what the inflection point means to me. How do we get to this? There are two ways. You can come from left to right or right to left. So left to right is basically like we have a problem. We have a problem to solve. We need to learn some code. What is the most straightforward solution that we have? This. How much do we know from the future? And what is the percentage that we know? Right? So we have like 99.999%. We are 99% sure that we will have this or this. Or we know that different bounded contexts will have different performance requirements or technology requirements. So if we do this straightforward, instead of splitting some of the services, that one is going to use Elasticsearch, the other one is going to use Postgres. So if we already know, how much, so coming from left to right is, how much are we willing to spend right now so we can at least be a tiny bit prepared when the things that are coming. So it's not so expensive. However, I don't want to pay a huge price right now. So how much do we want to go further? That's when you find this inflection point. Or we cannot go live without this or without this. So we need, but right now, knowing this, how much can we simplify our current solution story by story, but not lose sight of what we want to achieve? So those are the two ways that you can come up with this, and you can have this as a group discussion. We do that on our own every time. That's why we decide to start from somewhere. We just don't reason about that. Every one of you do that. Sometimes you don't reason exactly that, but you are using your previous experience. So unconsciously or subconsciously, you say like, yeah, when I used primitives everywhere and didn't have my types, I really got screwed because there was a ripple effect when I changed something. So you are doing this all the time. I'm just trying to find a way to visualize that and think about my own decisions. Another thing is how expensive, if you make a mistake, moving towards the future proof, how expensive it would be to remove that and go back to a simple state. That's another force that is in there. So to finish, yeah, I could be here for another five hours. So one way, like when we are in a group and different developers, so let's say that Felipe has an idea, I have an idea. So instead of, and then you are in a meeting full of developers and Felipe and I are discussing forever and everyone is bored and checking their phones. So to avoid this confrontation, what you can do, you say, okay, Felipe's idea is idea A. Sandro's idea is B. So now it's not Felipe's and Sandro's anymore. We have idea A and idea B. Forget about who created them. Don't treat those ideas as a final product, because the two people that created those ideas didn't have time to think about all the possibilities. But what they had in mind, what we should understand is this. What this idea is trying to optimize for, or to make it simple. What is this idea trying to do? The less you know, personally, if you're in a group discussion and you cannot agree, or it's very difficult to agree what's coming next, be as close to the straightforward as possible. The more uncertainty you have, the closer to this you should be. The more certainty you have, maybe it will get interesting to make some investment as well. I'm not advocating big design up front. I'm advocating just being smarter and work faster. Because that's where we are criticized by the hackers, right? So then once you understand this, then you ask these people, what are they trying to optimize for? Because maybe Felipe was worried about this, that I was not considering. And maybe I was worried about this, that he didn't consider. And in that, we may be able to find somewhere what would be the ideal point for us to start. And once again, this has absolutely zero to do with you. And if you suck at design, you will never be able to test drive anything, because your design you're going to suck, and then your test will be very difficult to do. But understanding these forces is what is important. I have lots of stuff to go through. But so basically, those are the things that are in my mind at the moment. I'm questioning everything that I'm doing. So the whole craftsmanship thing, detach that from XP. Craftsmanship is not XP. Craftsmanship is not TDD. It's not pair programming. It's not simple design. It's none of this. Those are amazing techniques that we use. So I cannot write code without writing tests because I don't struggle with that, and I love my workflow. I love this rhythm. But this is not craftsmanship. Those are the current techniques, the best techniques that I know today how to write software. But if we keep XP attached to craftsmanship, craftsmanship will die with XP practices. As soon as we find better ways of doing software, craftsmanship dies. And we cannot just take something that already exists and rebrand that under the banner of craftsmanship. Craftsmanship is all about, can we do things better? Can we question everything? The XP is not the Holy Bible. We don't have this shit, right? So we question everything. We try always to find good practices are only good until we find better ones to replace them. That's as simple as that. And that is craftsmanship. So we need to move away. We need to question. That's what's been on my mind. So yeah, I think that I don't have any time. So if you want to speak to me, come on. So thank you. But I'm completely on my own. So if I don't know about the 4 rules of simple design and many other design principles, there's zero prescription in here, right? So why is it difficult? Because this doesn't prescribe where do you start. So you have a feature, so you probably experienced that. Like you have a user story or something, you give that to different developers, and each developer starts from a different point. Some start from the middle, some from the beginning, some will start with the DIO or whatever, like the repository, whatever. There's no prescription in here. So all these decisions, like just the simple decision like, I'm going to start from here, that's a design decision. That has nothing to do with this. Right? So, and even when you say, I'm going to write a test, but you define which class you're going to have, the public method, the signature, the return type, this is all design. And at that point, it doesn't matter if you're doing that. You already decided which class you're going to have. This is not helping you with the design. Design is coming from your head. Right? So, but not all TDDs are the same. So that's another very important thing. TDD today is not a single thing. What are the 2 main styles of design? TDD leads to good design. And I strongly believe in that. The interesting thing about it is, why is it difficult for other people, right? And why is it not that difficult for me? But not only for me. There are a group of people that have no problems, but other people struggle a lot. So I was always thinking, why? And so as soon as another thing, like a lot of people can test drive the code, but not always the design is quite right after that. So what is missing, right? So I was thinking about that, and then what is the life cycle of TDD? What are the 3 steps? All right. Right? So that's what we learned. Doesn't everyone understand this? Right? Have you ever explained this to someone and the person didn't understand? Because like there's no way not to understand this. Right? You need to be a retard if you don't understand. Like write a failing test, make it pass, make it better. You cannot not understand this. Right? But applying that and achieving what we want to achieve is a completely different thing. So if this is so easy to understand, why is it so hard to do? Right? So, where is the design here? So, in TDD, where does the design happen? Refactor. What do we do in the refactoring phase? What's the guideline? Make code better. How do we do that? Right, so maintainable, readable, all the all the abilities, right? So what is the prescription here? What do we do? So just make the code better doesn't help. That's why we fail, right? So you say, make the code better, right? Yeah, how? What are we looking for? Generalize it. So has anyone ever heard about the 4 rules of simple design? Yeah? What are they? So I'll put in any order, right? Duplication.
Pass the test.
Pass the test is the first one.
No duplication. No.
Fewer elements.
So fewer elements is the last one. Fewer elements. And
Revealing time.
revealing times. So you find these written in different ways according to who wrote them. Where does this come from?
Back.
Kent Beck, right? Part of XP from the simple design. Is this part of TDD? No, it's not. So I asked Ron Jeffries if it is part, and he's one of the creators of TDD, of XP, alongside with Kent Beck, and it's not. So this is not TDD. Where's the design part of TDD if that's not part of TDD? So how come it's a design tool? Right? So for me, this thing is not a design tool. I changed my mind. So I've been inspecting how I work, and I completely changed my mind. For me, what this is a software development workflow. It's different. So this is my turn to write a failing test, but that means I specify the behavior that I want my system to have. This is me implementing the behavior that I want my system to have. And this is me trying to figure out, best of my abilities, how to make that thing better. All right, shall we start? Yay. Okay. So as I was saying, I'll start for the third time. So this book, I was talking about thinking fast and slow. So this book, I haven't finished yet, but it really changed the way I think, because it made me realize how biased I am towards certain things that I do. So sometimes we do things because either someone told us, or we heard so many times that that's the right thing, then we just believe that it's the right thing, and we stop questioning those things. And since, like, I don't know, 6 months ago, I started questioning how I work and all the techniques that I use, and understand, like, if I use them because I believe in them, or it's because it's just how I learned it, and a lot of people that I respect said that it was the right thing to do. So, how many of you use TDD? I would be very disappointed if I didn't see them. So, in the craftsmanship community. So, how many of you think that TDD leads to good design? Okay, you are biased now, right? Because you know the talk. So, because I said that for many years. Like, if you go back to my talks, books, and everything that I've said in the past 5 years, you will find in many places me saying TDD leads to good design.